Lecture problem 3. A 2.0 kilogram object traveling at 1.0 meters per second collides head-on with a 1.0 kilogram object initially at rest. Determine the velocity of each object after the impact if the collision is perfectly elastic. A simple diagram can be used to simplify this question. Before the collision, the bigger mass m1 has a velocity v1, is going to collide head-on with the smaller mass m2, which is initially at rest. After the collision, the two masses are going to have different velocities, but since the collision is head-on, the two velocities v1 final and v2 final are going to remain along the same line of motion of m1 before the collision. This question is a direct application of the earlier video in which I have derived for you the algebraic expressions for an elastic head-on collision. The velocity v1 final was found to equal m1 minus m2 times the velocity v1 divided by the sum of the two masses, m1 plus m2. And the velocity v2 final was found to equal 2 times m1 v1 divided by the sum of the two masses. Substituting the masses and the velocity v1 into these two expressions, you can find that the velocity v1 final is going to equal 0.33 meters per second, and the velocity v2 final is going to equal 1.33 meters per second. But for the fun of it, let's solve this question step by step like we did in the other video. Because the collision is happening while the net force is equal to 0, therefore the momentum is conserved. The momentum initial equals the momentum final. The momentum initial comes from the mass m1 times its velocity v1 plus the mass m2 times its velocity v2. After the collision, you have the mass m1 moving with the velocity v1 final plus the mass m2 times its velocity v2 final. Since this collision is a one-dimensional collision, therefore we have the x component only. m1 v1 has a positive component. m2 v2 is equal to 0. That is going to equal m1 times v1 final. Since we don't want to predict the direction of the v1 final, therefore leave it in a positive form, the numerical answer will predict its direction, plus m2 v2 final, which for sure travels towards the positive direction. Bring the like terms to the left hand side of the equation, therefore m1 v1 minus m1 v1 final, that's going to equal m2 v2 final. Factorize the mass m1 from the left hand side terms. The right hand side stays as m2 v2 final. Now you can substitute for the known quantities. m1 is equal to 2, v1 is equal to 1.0 minus v1 final equals m2 is equal to 1 times v2 final. As a result, the v2 final is equal to 2 times 1 minus v1 final. Now we are going to do pretty much the same thing using the conservation of energy. The kinetic energy before the collision equals the kinetic energy after the collision. Before the collision we have 1/2 m1 v1 squared plus 0 because the second mass is initially at rest. After the collision, both masses are moving m1 is moving with the speed v1 final, therefore 1/2 m1 v1 final squared plus 1/2 m2 v2 final squared. Cancel the halves. Move the like terms to the left hand side of the equation, therefore m1 v1 squared minus m1 v1 final squared equals m2 v2 final squared. Factorize the m1. You end up with m1 times v1 squared minus v1 final squared equals m2 v2 final squared. Now you can substitute for the known quantities. m1 is equal to 2.0, v1 is equal to 1.0 minus v1 final squared. Close the parenthesis. That is going to equal m2 is equal to 1.0 times v2 final squared. Apply the difference of the square relationship to this term. This becomes 2 times 1 minus v1 final times 1 plus v1 final equals the v2 final was found earlier to equal 2 times 1 minus v1 final. Let's substitute for that expression. Because it's in a squared form, the 2 becomes 4 times 1 minus v1 final squared. The term 1 minus v1 final is going to cancel with the square here. The 4 and the 2 are going to simplify 2 to 1. Therefore, this expression is going to be very simple. 1 plus v1 final, that's the only term left on the left hand side, is going to equal 2 times 1 minus v1 final. Distribute the 2 here. Now we have 1 plus v1 final equals 2 minus 2v1 final. Now bring the v1 final terms together. You end up with v1 final plus 2v1 final equals 2 minus 1. Therefore, 3 times v1 final equals to 1. Solving for the v1 final, we obtain 0.33 as mentioned earlier, meters per second. To solve for the v2 final, substitute the v1 final in the expression that we have obtained earlier, which is 2 times 1 minus v1 final. This is going to be 2 times 1 minus 0.33. Solve for the v2 final, you obtain 1.33 meters per second.